Okay, students, let us go to another topics. Elevation in boiling point. Elevation in boiling point. So another topic from the chapter solution. We can discuss it in detail. What is the elevation in boiling point? Before that, we should know what is a boiling point and what is a vapor pressure. We have already discussed what is a boiling point and what is a vapor pressure. I will give you one example. Okay, imagine this bottle water, this much is water, this topic is, this portion is empty. Okay, will you say this is truly empty? Now, there are a lot of water vapors are here, filled here, and that water vapor is in equilibrium with this liquid water at this temperature. You know, this vaporization has been happened from this surface waters. There is no vaporization from here, only from here. Vaporization always happens at the surface. Why not vaporization from bulk? The reason is that if a vapor is formed from here, that will be suppressed by the liquid pressure. Because vapor pressure is lower than the surrounding pressure, that's we call the vapor. That is why vaporization only happens from the surface. But suppose you increase the temperature, vaporization also increases, vapor pressure also increases, but at a particular temperature, water starts to boiling. How do you identify that water has been boiled, boiling happened? Because you will see the bubble. What is a bubble? Bubble is a gaseous state within the liquid state. Bubble is a gaseous state which is surrounded by liquids. Bubble, there is water vapor, it has a pressure that is called vapor pressure. At the boiling point, vapor pressure inside the bubble is very high. That can overtake the surrounding pressure. That is why bubble is formed even from the bottom, and bulk. Okay, only that condition water is boiled. Therefore, boiling is the bubble. Boiling is the process where bubbling happens. When the bubbling happens, because the pressure of the bubble is greater or equal to atmospheric pressure. Therefore, boiling temperature is a temperature at which vapor pressure means pressure of the inside the bubble or vapor pressure is equal to atmospheric pressure. The atmospheric pressure normally is 180. Now, if you decrease the atmospheric pressure, that is 0.518, you can do that. You remove the air from the room and seal the room. The vapor pressure will be less, atmospheric pressure will be less. In that condition, the bubbling or boiling will happen at lower temperature. Having learned that egg cannot boil at a mountain top, because at the mountain top atmospheric pressure is very less. Therefore, water boiled at a lower temperature. You can even boil the water, still that boiling water will be cool. That's possible. How? You lower the atmospheric pressure extremely low. Okay. Suppose 0.1 atm, you make it to 0.1 atm, your water will boil at 10 degree to 12 degree. 10 degree, 12 degree means cold water, but water will boil like that. Very funny. That's possible. Okay. Now you have two container. In one container we have pure solvent, and another container we have equal amount of solution of non-volatile solute. Then this portion containing the water vapor, this portion also contains the vapor. The vapor is only from the solvent. Solute will not be vaporized. Have you noticed that here I have more circle than this? That is the vapor at any temperature, this vapor pressure, that is P0, is greater than this vapor pressure, that is P. Now suppose at 100 degree this P0, 90 degree this P0, 90 degree this is P, P0 greater than P. 100 degree this P0 increased, vapor pressure of pure solvent increased and become 1 atm. This 100 degree, will it be 1 atm? No, it is less than 1 atm. To make it 1 atm, what is a 1 atm? Normal atmospheric pressure, you have to increase the temperature. Suppose 110 degree. Okay, then only that is become 1 atm. Only that temperature the solution become boiled. Only that temperature solution boils. Therefore, this increase in temperature from 100 to 110 degree, when solute is added, that is called the elevation in boiling point. Is it clear? Elevation in boiling point. Now we can graphically express that. Okay, you can graphically express. Suppose you have this is temperature degree centigrade. This is pressure, vapor pressure. You know, this 0. Suppose it is 180. This value is 180. 0. When temperature increases, suppose a pure solvent, in the pure solvent, temperature increases, vapor pressure increases like this. Okay? Temperature increases, vapor pressure increases. And this point, this is 180 point. This is the this is a temperature at which vapor pressure is equal to 180. Therefore, you can call it is TB, boiling point of pure solvent. This is solvent. Now, in this, when you draw the solution, at this temperature, the vapor pressure of solution is always less. We noted that at any temperature, vapor pressure of solution will be less. At this temperature, vapor pressure will be, suppose, it also increases, but it is lower than the solvent. Therefore, you will get a graph like this. Look at here, solution. At this temperature, the temperature where pure solvent boil, its vapor pressure is not equal to 180. Therefore, solution will not boil at that temperature. You increase again. Temperature increases, you increase again. Okay. Yes, you got this value. This is T dash. Yes. That is TB less than T dash. This is the boiling point of solution. TB is the boiling point of solvent. T dash is the boiling point of solution. Therefore, T dash minus TB is equal to delta TB. That is elevation in boiling point. This T delta TB directly proportional to mole fraction, molality or delta TB is equal to Kb into M. What is M? M is called molality. Kb is called the elevation in boiling point. This is called the molar elevation constant. Kb, the value of Kb is equal to mRT square divided by 1000 delta H vaporization, delta H0 vaporization. Where M is equal to, please write down, M is equal to molar mass of solvent, R gas constant, TB is the boiling point of the solvent, 1000. This is enthalpy of vaporization. MRT square 1000 delta H0 V. Now, I just derive this equation. It is not the part of the NCERT syllabus. I just try to derive this equation. It is not the part of the NCERT syllabus, but for IIT it is very important. That's why. In thermodynamics, we have learned Clapeyron equation. Clapeyron equation. That is ln K2 divided by K1 is equal to delta H0 by R 1 by T2 minus 1 by T1. Where K2 is the equilibrium constant at T2, K1 is the equilibrium constant at T1. We have similar equation in Arrhenius equation also. Same. Now, here our equation is vapor-liquid equilibrium, physical equilibrium. Therefore, this equilibrium, there is a gaseous state involved, therefore it can be represented as Kp. Kp, which is directly proportional to pressure, because Kp directly proportional. Therefore, I just rearrange this. Ln P0 divided by P1. P0 is the vapor pressure of pure solvent. P1 is the vapor pressure of solution. Is equal to delta H0 by R T1 minus T2, that is T2 minus T1 divided by T1 T2. But we can imagine that T2 is the boiling point of solution, T1 is the boiling point of solvent. Therefore, T2 minus T1 can be taken as delta Tb. This is delta Tb. And we have also assumed that T1 almost equal to T2, therefore T square. An assumption. Really sorry. Because one is 100 and other one is 110 or 105 or 101, that's difference only. Therefore only for convenience. Otherwise you can use like this also, no problem. Into delta H0 by R is equal to P0 minus P1 ln. Now we just rearrange that, minus ln P1 by P0 is equal to delta H0 by R delta Tb by T square. We just rearrange like this. Now we know that P is equal to XA into P0. What is P1? Vapor pressure of the solution. What is P0? Vapor pressure of pure solvent. Vapor pressure of a solution, P1 is equal to mole fraction of that solvent into vapor pressure of solvent in pure form. We learned. Therefore, when you apply that here, P0 and P0 cancelled. That is, you will get to minus ln XA is equal to delta H0 by R into delta Tb by T square. This is delta Tb is the elevation in boiling point. Now, minus ln XA means minus ln XA 1 minus XB is equal to delta H0 R divided by delta Tb by T square. Now, ln 1 minus XB is almost equal to minus XB, minus into minus XB. This is mathematics. If XB is very small, ln 1 minus XB is equal to minus XB. It's a mathematics. Therefore, this is XB. XB is equal to delta H0 by R delta Tb by T square. Now, SB is equal to NB divided by NA plus NB. This NB, downward NB almost neglected. NB divided by NA is equal to delta H0 by R into delta Tb by T square. Now NB divided by, this is nothing but WA divided by MA solvent is equal to delta H0 by R delta Tb by T square. Okay. Now, this is number of moles of solvent, and this is a what is this? Volume of solvent. Therefore, NB divided by WA is equal to delta H0 divided by R into delta Tb by T square into MA. Okay. Okay. Now, suppose it is in gram. You make it in kilogram. If it is kilogram, make it in gram. Therefore, this term number of moles of solvent per gram, number of moles of solute divided by mass of the solvent. This is a molality. Therefore, molality is equal to delta H0 by R into delta TB by T square into Ma. Okay. Now you bring all this. This I am really this this Ma will be here into 1 by Ma. Okay, because it is upside, therefore it's down. Therefore keep delta TB here. Therefore M molality into R T square Ma divided by delta H0 is equal to delta TB. T. Okay, that is delta TB directly proportional to M molality. This entire term is called kb. There will be 1,000 if you convert this kilogram into gram. There will be 1,000. Okay. Yes. This is kb. This is how we derive the equation.